naming Diyos. Maraming salamat po sa buhay at lakas na aming taglay, sa liwanag ng kaisipan at sa pagkakataong maipagpatuloy ang pag-aaral ng mga kabataan. Gabayan po ang bawat isa sa amin. Anuman ang bahagi na aming gagampanan, naway maging maayos at matagumpay ang pagtuturo at pag-aaral na aming gagawin sa araw na ito. Patawarin mo po kami sa aming mga pagkulang at pagkakasala. At sa aming paggawa, ikaw po ang aming makasama. Amen.
Hello, good morning. I'm Dr. John Mark E. Burgos, your teacher in statistics and probability. Our objectives for today are formulating appropriate null and alternative hypotheses on a population mean and identifying appropriate form of test statistics when the central theorem is to be used. First of all, let us have an activity. Let's have it in a multiple choice type. I would request you to encircle the letter of the correct answer. So if you are ready, I will give you 5 seconds to answer each question. Let's proceed first with the first question. What kind of parameter is applied in the given situation? The mean height of all grade 10 students is 170 centimeters. Is it A, mean? Is it B, variance? Is it C, proportion? Or is it D, standard deviation? 10 seconds. All right, time is up. The correct answer is A, mean. Number 2, a licensed teacher claims that more than 40% of all education graduates passed the licensure examination for teachers. What kind of parameter is used in this claim? Is it A, mean, B, variance, C, proportion, or D, standard deviation? 10 seconds. Okay, time is up. The answer is C, proportion. Third question. It is a classification of error wherein the decision is to reject the null hypothesis that is true. Is it A, correct decision, B, type 1 error, C, type 2 error, or letter D, type 3 error? All right, time is up. The correct answer is B, type 1 error. Fourth question. It is also known as non-directional test. What is the answer? Is it A, one-tailed test, B, a tailed test, C, a two-tailed test, or D, is it a three-tailed test? 10 seconds. Okay, time is up. The correct answer for number 4 is C, two-tailed test. And the fifth answer is, which of the following is not a parameter? Is it A, the mean, B, the mode, C, the population variance, or is it D, standard deviation? What is the correct answer? 10 seconds. So which of the following is not a parameter? The answer is B, mode. Let's proceed now to our first objectives, formulating appropriate null and alternative hypotheses on a population mean. Let's define first statistical hypothesis. It is an assertion or conjecture concerning one or more populations. It is an assumption or statement which may or may not be true concerning one or more population. There are two types of statistical hypotheses. The first one is null hypothesis, and it is symbolized by a capital H and a small o. The null hypothesis states that there is no difference between population parameters and the hypothesized value. It is a hypothesis that the population means equals a specific value. Therefore, we can expect from the null hypothesis that it will use the following mathematical symbols: the equal sign, the greater than or equal to, and the less than or equal to signs. The second one is the alternative hypothesis. It is symbolized by a capital H and a small letter a. It is a claim about the population that is contradictory to HO and what we conclude when we reject HO. The alternative hypothesis says the population mean is greater than or less than or not equal to the value we assume, which is true in the null hypothesis. Therefore, in the alternative hypothesis, we can expect that we will be using the symbols greater than, less than, and not equal to signs. To state the null and alternative hypothesis correctly, here are the following things we have to do and we have to remember. Number one, identify the parameter in a given problem. Secondly, identify the claim to be tested that may show up in null or alternative hypothesis. Third, translate the claim into mathematical symbols or notations. And the last one, formulate first the null hypothesis, symbolized by HO, of course, then the alternative hypothesis, symbolized by HA, based on the three different ways in writing hypothesis. It is symbolized as most equal, or mean is less than or equal to, and mean is greater than or equal to. In choosing the difference or determining the difference between a one-tailed and two-tailed test, a one-tailed test has an alternative hypothesis and contains the greater than symbol or the less than symbol, while in the two-tailed test, it is the alternative that contains the inequality symbol or not equal to symbol. In the one-tailed test also, it is directional and either it is right-tailed or left-tailed. But in the two-tailed test, it has no direction. Let's have our first example. A manufacturer of soft drinks claims that all labeled 1.5 liter bottles contain an average of 1.48 liters of soft drinks. A retailer wishes to test whether the mean amount of soft drinks in labeled 1.5 liter bottle is less than 1.48 liters. So sa madalit salita, in short, there is a conflict here between the retailer and the salesperson. The salesperson will claim the HO and the retailer will claim the HA. The seller will claim it as the labeled bottle contains 1.48 liters, while the seller will claim that the bottle or the labeled bottle is less than 1.48 liters. If you will determine the direction, it is directional, either right-tailed or left-tailed. Let's have the second example. The average power consumption of air conditioner is at most 2,500 watts, as claimed by the owner. A survey made by an electric power company found out that the mean consumption is 3,500 with standard deviation of 225. So what will be the claim of the owner? Of course, the owner will claim the null hypothesis, which is HO, or the power consumption is 2,500 watts. On the other hand, it will be contradicted by someone who made the survey by claiming that, of course, he will be using the alternative hypothesis, or HA. He will be claiming that the power consumption is greater than 2,500 watts. To make a conclusion, it is directional. It may either be right-tailed or left-tailed. But to be specific, since it is greater than 2,500, we can claim that it is right-tailed. Because in the right tail of the normal distribution, we are always using that for the positive value. And since greater is on the side of the positive value, therefore it is right-tailed. Let us have an exercise. In these exercises, we shall write the null and alternative hypothesis of the following and determine if it is one-tailed or two-tailed. Now, I will be giving you 20 seconds to answer each question. So, if you're ready, let's start now. First exercise. A car manufacturer claims that the mean selling price of all cars manufactured is only 160,000 pesos. A consumer agency wants to test whether the mean selling price of all the cars manufactured exceeds 160,000 pesos. So you have 20 seconds to write the null and alternative hypothesis and determine if it is one-tailed or two-tailed. Ready? Go. All right, 20 seconds have passed. So the null hypothesis will be the selling price of all cars is 160,000 pesos as claimed by the car manufacturer. And the alternative hypothesis will be the selling price of all cars exceeds 160,000 pesos. Why exceed? Always remember that the alternative hypothesis is always contradictory to the statement of the null hypothesis. And since the alternative hypothesis is exceeds 160,000 pesos, it is in the directional or in the right tail. Always remember that when you say exceeds, we are dealing on the positive side of the normal curve, and if that is on the positive side, that will be right-tailed. Second question. A bus company in Manila claims that the mean waiting time for a bus during rush hour is less than 12 minutes. Take note that in the statement, the claim of the bus company is less than 12 minutes. Now, a random sample of 30 waiting times has a mean of 15 minutes with a standard deviation of 4 to 8 minutes. Again, you have 20 seconds to write the null hypothesis, the alternative hypothesis, and you have to determine if it is one-tailed or two-tailed. Ready? Go. Since the bus company claims that it is less than 12 minutes, the null hypothesis will be the waiting time is less than 12 minutes. And since the alternative hypothesis always contradicts the null hypothesis, the alternative hypothesis will be the waiting time is greater than 12 minutes. And since the alternative hypothesis claims that it is greater than 12 minutes, it is directional and in the right tail. Let's proceed to the second objective. Identifies the appropriate form of test statistic when the central theorem is to be used. Let's define first test statistics. It is used to calculate the p-value of your results, helping to decide whether to reject your null hypothesis. The larger the test statistic, the smaller the p-value, and the more likely you are to reject the null hypothesis. We have here the table of differences between the population variance, which is known, the population variance, which is unknown, and the central limit theorem. In the population variance, if it is known, the population is normally distributed. If it is unknown, the population is normal or normally distributed. And in the central limit theorem, the population may not be normally distributed. In the population variance, if it is known, the n or the sample will be greater than or equal to 30. But if it is unknown, the sample, the number of samples will be less than 30. And in the central limit theorem, it is greater than or equal to 30 or considered sufficiently large. If the population variance is known, the population standard deviation is also known. If the population variance is unknown, the sample standard deviation is known, and the population standard deviation is unknown. But in the central limit theorem, the variance can be known or unknown. In the population variance, if it is known, we will be using the z-test. If it is unknown, we will be using the t-test. And in the central limit theorem, we use the z-test by replacing population standard by sample standard deviation. Let us have our first example. A study was conducted to look at the average time the students exercise. A research claimed that in average, students exercise less than 12 hours per month. In a random sample size, take note of this, in a random sample size of 110, remember that is 110, it was found that the mean time the students exercise has a mean of 11.3 hours per month, with a sample standard deviation of 6.40 hours per month. Now, since the sample size is 110, the sample size is large and the variance is unknown. Therefore, we will be using the z-test, which will be the appropriate tool in the central limit theorem. Let's have our second example. An English teacher wanted to test whether the mean reading speed of students is 540 words per minute. A sample of 10 students revealed a sample mean of 520 words per minute with a standard deviation of 5 words per minute. At 0.05 significant level, the reading speed is different from 540 words per minute. Now, is it different from 540 words per minute? The sample size or small n is 10, which is less than 30. And the sample standard deviation, which is 5 words per minute, was given. Always remember that in this objective, we are tasked to determine if we will be using the z-test or the t-test. Now, since the number of sample is 10 only, therefore, the appropriate test is t-test. In the third example, a study was conducted to look at the average time the students practice solving math problems. A researcher claimed that in average, the students practice solving math problems is less than 12 hours per month. In a random sample, which has a size of n, which is 110, it was found that the mean time students practice is 11.3 hours per month with a standard deviation of 6.40 hours per month. Now, let's remember this. Since n, or the number of samples, is 110, the sample size is large. When you say large, that's greater than 30. And the variance is unknown. So what are we going to use? Hence, we will be using the z-test, which is the appropriate tool according to the central limit theorem. In our fourth example, an English teacher wanted to test whether the mean reading speed of students is 540 words per minute. A sample of 10 students, remember that, 10 students revealed a sample mean of 520 words per minute with a standard deviation of 5 words per minute. At 0.05 significance level, is the reading speed different from 540 words per minute? Now, remember that the sample size or n is 10, which is less than 30. And the sample standard deviation of 5 words per minute was given. Therefore, the appropriate test is t-test. Let's have a practice. In the following exercise, we shall identify the appropriate test statistic to be used in each problem. Write z-test or t-test on a separate sheet of paper. Now, I will be giving you 10 seconds only in each exercise. So if you're ready, let's have the first question. A sample of n, which is equal to 20, is selected from a normal population mean of 53 and a standard deviation of 10. So what test statistic is to be used? 10 seconds. Okay, do you have the answer? Yes, you're correct. It's t-test. Second question. Based on the report of the school nurse, the average height of grade 11 students has increased. 5 years ago, the average height of 11 students was 168 centimeters with a standard deviation of 36 centimeters. She took a random sample of 150 students and derived the average height of 159 centimeters. Remember, that is 150 students. So what statistic test are we going to use? 10 seconds. Yes, you are correct. It's z-test. Third question. Knowing from a previous study that the average of athletes is 60, an athletic advisor asked how his soccer players are academically doing as compared to other student athletes. After an initiative to help improve the average of student athletes, the advisor randomly selected 15 soccer players and found 80 as the average with standard deviation of 120 or 1.20. Remember, 15 soccer players. What statistic test are we going to use? 10 seconds. All right? You are correct. Yes, it's G-test. So, let's proceed now to our question and answer. If you have any inquiries or if you have any questions, you can type that in the FB live stream and let's have it. We will be answering that later. All right? We have a question here. The question says, what is a good hypothesis statement? That's a very good question. What is a good hypothesis statement? Right? Now, to answer that question, a good hypothesis statement should have the following. Remember this, it should have the following. First, it should include an if and then statement. Secondly, it includes both the independent and the dependent variables. Third, be testable by experiment, survey, or other scientifically sound technique. Fourth, we should base on information in prior research. It's either this prior research is either it is yours or someone else. And number 5, have a design criteria, or this is for engineering or programming projects. Thank you very much. I hope you learned something from our lesson. And most especially, I hope you will be applying this in our everyday lives. Let's remember that statistics and probability is very applicable in our everyday lives. So, see you next meeting and God bless.